So in this next slide, I'm showing you how to deal with all this complexity, how to do this knowledge management for purposes of decision making. I selected for this purpose the Delphi approach, or the Delphi method. It is called like this because it's about trying to anticipate, so it refers a bit to the ancient oracle of Delphi from ancient Greece. But it's a scientific approach. This approach, before I'm beginning to explain what you see on the slide, it's about bringing together a group of experts in an exercise of coordination so that they take a collective decision about an issue. How do you do that? You, as a leader of the process, invite a number of individuals, experts from different fields, can be 10, can be 20, the number that you decide. And then you address them a list of questions which they answer as experts. So they take an expert decision for each answer that they give you. You collect all these answers from all these experts, make a report which you then distribute back to each of them and ask them to answer again the same questions. When they do it again, they already adjusted their answer because now they understand better what the others have to say about this issue. So they integrated the other knowledge already in their own answers. So you already understand that this is a great way to deal with the issue of lack of integration between disciplines of science, because you don't try to create an overall general theory about everything in science. You rely yourself on the experience and the expertise of your experts. When they generate a final report under your leadership, potentially make them vote, or other ways of making the collective decision, this is the best result that you can obtain for the issue under discussion. Now, this method has different versions. Usually, these experts don't meet live, so you can do that yourself by communicating with all of them. Why usually they don't meet? Because you want to avoid the social games and everyone defending their own turf and position when they are facing each other and potentially having opposing views. You just want them to focus on the issue. But this can be adapted to a live situation, especially when you want a quick decision upon an issue. And if you think you have a way to manage this live interaction, it can be hard, so you need somebody that is experienced in that, or you launch yourself and you learn in the process. Now, this method has basically two phases, and here I'm going to present two of them according to the version that I developed myself in my work. First of all, you want these experts to reach a common list of priorities. In my version, I have the experts in a workshop live, so that they can quickly exchange, so that they can formulate issues, a list of issues. Then they can vote on the issues, which one should come first, and so on. There are different methods to make them vote. And after you ranked those, you consolidated those, you select the top 3 or 4, depending how many you need. You should not select too many, because then it becomes too hard to handle. Then you formulate each of that issue as a decision question. So in the phase 1, you see here that I've selected 3 issues, 3 priorities, P1, 2, and 3. These are the most important, starting from the bottom. And then in the next phase, what you do, you formulate these issues as questions that can be answered in the most simple way possible, which is yes or no. That's the most simple way possible. So it takes some skill and deliberation in the formulation of the issues and the formulation of the question. And then, if you put them into what I call here decision tree, then you obtain a framework in which you can map different pathways for the evolution of a community, for example, or a technology. And I'm going to show you in the next slides what this means. So I hope I explained it clearly, but if not, we can discuss further by email and live when we can. So for example, what you can obtain in a city, and this is an example that I take from this article that I also put it for your reading. It's, for example, the city of Vancouver, and you want to see what decision will be taken according to these questions. Do you make a city, let's say we are in Vancouver, the community of people in Vancouver. Do we have a city plan for adaptation to climate changes? Yes or no? If no, of course, do nothing scenario. If yes, then you address the next question, which is, do you make a city plan for curbing greenhouse gas emissions? Yes or no? If you say no, you stop there, adapt to risk. If you say yes, you continue with the next question, and which is in this case city plan for strong mitigation responses. Now, this is a bit abstract, so you need also to work out with the details. If you go in the article, you see the details. But the point is that you can see where you stop. If you always answer yes, yes, then you are in the best situation possible, because you continue to advance and you take the next issue and so on. This decision tree, or binary decision tree because it's yes, no, can be adapted for different purposes. And here I give an example for a transition to sustainable urban water management. So if your issue of concern is water, then for example, your first question can be, do we make an urban metabolism based water policy? That is, do we develop a water policy based on models of urban metabolism? It's a bit technical. Second, do we make a policy of water for cross-sectoral integrated thinking and management or not? And also, do we make a long-term policy for innovation for urban sustainability? If you answer yes, you evolve. Now, here, actually, by the way, I present a more generalized typology of scenarios, where the first one is status quo, like do nothing. Then where you advanced a bit, you did something, but it's insufficient. Like you go up a bit and then you stop to the right. And then the next one would be promising. And then best hope, because you continue to improve yourself. The same approach can be applied to our own policy related to, if you remember in the previous slides, the evolution of the cities. If you cross the innovability threshold, and then if you cross the sustainability threshold, and at the beginning if you start pioneering projects for changing your city. These thresholds then correspond to your questions. In the same time, if you remember from previous slides, from the systemic view upon sustainability, we derived sustainability filters. First ecological sustainability filters, and social and economic sustainability filters. Now, if you apply this in this order, you obtain the same type of scenarios: status quo, insufficient, promising, and best hope. But then you have details. Depending how you defined your filters, you obtain the description of your scenarios, saying that yes, we have this point 1, we answer it, which means these details. Then we answered point 2, which means these details, but we stopped at point 3. So we are kind of promising, but we're not doing the best that we can. Now that was the main point that I wanted to make, and I will be waiting for your questions, and we can discuss about that. If you want, you can read this article. If not, just ask me to explain better this method. And you can, of course, also seek for yourself different approaches for knowledge management. I just want to stress here that you will have separate discussions about scenarios in this program. This was just an introduction to the Delphi approach that can be linked to decision trees. So I hope this is helpful for you, and that's it for now. Thank you.